Hi and welcome to another episode of Mission Control. One of my subscribers suggested that I do a video on equatorial mounts, and I agree. My channel of course needs a video on that too. Equatorial mounts are one of the best proofs for a globe, and they absolutely cannot work on a flat Earth. Wolfie6020 has done a lot of great videos on the matter, and there's no way I can keep pace with that, nor get anywhere near the same NASA paycheck. However, what I can do is try to animate the principles of an equatorial mount. So let's have a look at that. Here's a telescope on the North Pole. Let's move it south to 55 degrees north latitude. To compensate for the Earth's rotation, the mount can be aligned accordingly so that it will always point true north. This is called polar alignment. Once aligned to the polar axis, we can now rotate the telescope around the declination and ascension axis to point to a celestial object. Now that the telescope is pointing to the desired object, all we are left to do is turn the ascension axis by 15 degrees per hour to track the object. Notice that the tracking is done by a single axis of rotation only. Let's try to do this on a flat Earth. I've chosen the AE map because it's the most popular one, but it doesn't make any difference as long as it's anything other than a sphere. Let's go back to 55 degrees north latitude, which means that the mount is tilted 35 degrees relative to the polar axis. This implies, by the way, that the North Star has to be situated 5,560 kilometers above the North Pole, according to simple geometry. The flat Earth is said to be a stationary one, so this entails that it's the celestial objects that are rotating in the sky. The telescope is now aimed at this random star, so let's begin tracking it by rotating the ascension axis 15 degrees per hour like we did before. This is not looking good for the flat earthers. The equatorial mount is now tracking anything else but that star. So what's going on here? Well, since the Earth is a spinning sphere and all the stars are pretty much fixed, it only takes a single axis of rotation to track them. On the flat Earth, stars are moving in circles, and you can't track a circular motion without involving two axes of rotation. If flat earthers can't explain how an equatorial mount works on their flat Earth of choice, they're not worth listening to. I believe this was another safe landing for the Globe team, so stick around for the next mission.